Alright, so we continue here on our quest to multiply polynomials. It's so nice because there's not that much new stuff to learn here. We've already learned all the major rules for algebra. It's so sweet. Now we just coast. Lincoln said if he had 8 hours to chop down a tree, he would spend the first 6 hours just sharpening the axe. That's what we've done in this course. We've spent the first 6 weeks just learning the rules. Now it's easy because all these polynomials play by the rules we've learned, all the axioms. Alright, talk is cheap, let's do it. Binomial times binomial. I want to do this 3 different ways, just for fun. Okay, first way that I want to do it would be using the this is using the distributive law method. Okay, and it would go like this. You could think about this as one item, and you would distribute it to 2 items here. You have two terms, so it would look like this. It would look like 5x plus 1 times 3x plus 5x plus 1 times 1. This is of course using the distributive law. Then you could play the same game on each of these pieces. You could say, well, this has 2 terms in here, so I could take this one and distribute it in there 2 times. So this would look like 5x times 3x plus 1 times 3x. And of course I could do the same thing here. I have 2 items here, so this could get distributed to each of them. So that would look like this: 5x times 1 plus 1 times 1. And of course this is the distributive law. Now this is so famous when you have a binomial times a binomial that we collapse these steps into something famous called FOIL, first, outer, inner, last, meaning that the first 2 are multiplied. These are the first 2, they go there. The outer ones, the 5x and the 1, they go there. The inner ones, the 3x and the 1, go there. And the last ones, they go there. So often people will jump from this step to that step and say, well, that's by a FOIL. Really what we're doing there with FOIL is just a couple distributive laws. Hope that's clear. But let's continue here. This will give me a total of 5x. That would give me 15, and x times x would give you x squared. A 1 times a 3x would just give you 3x. So 5x times 1 would just give you 5x. 1 times 1 is just 1, and then you're pretty much done. It's customary to simplify if you can. In this case I have 2 like terms, an x and an x, so I could combine them and say this is 15x squared plus 8x plus 1, and there you go. Beautiful. This is using the distributive law a couple times. Okay, that's one way to do it. And now what I'd like to do is do it a different way. This time I'm going to show you the FOIL thing that I just talked about. FOIL would mean that you take the first one, so you go 5x times 3x plus, that's the first one. The outer, 5x times 1, that's the outer. The inner, that's the inner, 1 times 3x. And the last, 1 times 1, and I would say this is by FOIL. We just proved it a couple of minutes ago. That's by FOIL. And then that would give you, of course, 15x squared plus 5x plus 3x plus 1. This is just by inspection. And then, of course, you could collect like terms. 15x squared plus, these 2 are like terms. They're both degree 1. 8x plus 1. And there you go, yippee-ki-yay. We did it using the FOIL that we just learned. But that was so fun that I think I want to do it yet again a different way. Why not? Let's try something now. This is by the kindergarten method. Okay, so that's where we stack them. So I have 5x plus 1 and 3x plus 1, and that is times. And so now I go 1 times 1 is 1, 1 times 5x is 5x, and I'm done with the 1. I distributed that one. Now I have to distribute the 3x. The 3x times 1 is 3x. The 3x times 5x, that's 15, and an x would give you x squared. And then I add them. I add like terms together, 8x, 15x squared. And there you go. This is by kindergarten method, the 3rd way. How nice is that? So pick your favorite. Nice ways of multiplying a binomial times binomial. This is nice because it works on any binomial times any binomial. It'll always work. Sometimes they don't line up nice, so you have to leave placeholders. For example, this may be degree 3 and this may be degree 5, and so you couldn't add them together because they're unlike terms, so you'd have just two separate things here. But regardless of that, this method will always work for any polynomial times any polynomial. It's so good. It's so clear too. Alright, shall we try another one?